Hello everyone, this is Prashanth, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Let's continue with the last lecture. In last lecture, just I have completed about cloud storage, cloud storage models along with the classifications, advantages, disadvantages, how many types of cloud storage models that will exist in the Internet of Things. These are the things I discussed in the last class. Just in the types of cloud storage model, just like virtual storage, physical storage, like that we have different types of virtual cloud storage models in principles of IoT that can discussed in the last lecture. So now we move entering into the actual content of step by step guide. Just before cloud storage model, we have some uh, communication models and communication APIs, application programming interfaces. So along with based on the communication API, so according to our syllabus here we have two types of communication APIs that is first one REST, representational state transfer communication API, and web services or web based communication API. These are the two communication APIs we have. So based on that, depending on that, just we are going to elaborate, we are going to define, or we are going to describe on building a RESTful API with Flask here. So I am going to explain step by step. So in first step what we are doing, in second step what we are doing, third step, fourth step, fifth step, we are having only 5 steps. So our topic here, the main here, building a RESTful representational state transfer API, application programming interface with the Flask method. So that will step by step guide. So here, before entering into the actual building of RESTful API, first we have to know about the REST API introduction. What is REST? What is API? What is introduction? What is the minimal things here? So the REST is nothing but this is one kind of communication API. So it follows exclusive pair communication model features. Along with that, I'm going to introduce along with the application programming interface, that is API. So here, REST stands for representational state transfer. Is an architecture style. It defines a set of constraints to be used for creating web services. So in order to create web services, so based on that RESTful communication API, so we use here the architecture style here. So here, this is the introduction point of REST API. So REST API is a way of accessing web services in a simple and flexible way without having any processing of the data. That is the some second important point regarding REST API. So REST technology is generally preferred to the more robust, simple object access protocol. Simple object access protocol technology, because REST uses less bandwidth, simple and flexible, making it more suitable for internet usage. So this is the just what are the preference of RESTful API. Next, it is used for fetch or give some information about, from a web services. This is no. All communication done via REST API uses only HTTP request only. So we already know RESTful communication API, just it depends on the HTTP request only. So the models are different, communication APIs are different. So these are the some introduction points regarding representational state transfer application programming interface introduction points. Next, architectural view of REST here. So what is the working? So here a request is sent from the, just it follows the request response communication model. So we have APIs. Before that we have models, some communication models. We already know, I already told many times in previous lectures. Communication models are publish subscribe communication model, request to response communication model, exclusive pair communication model, push-pull communication model. So these are the communication models available in the Internet of Things. Apart from that, we have communication APIs, application programming interface. So the application programming interface are RESTful communication API and web service WebSocket communication API. So the REST, it follows the principle of request response communication model. So here it is sent from the client server into from a web URL, just www.iare.ac. Just I can type this website in URL as HTTP get, post or put or delete the request based on the these HTTP codes, get request, post request, put or delete request. So based on that we have send URL, type URL in the URL tab. So after that a response come back from the server in the form of a resource, which can be anything like HTML, XML or images or JSON. But now JSON is the most popular format being in web services. So this is the actual process is going on in REST between the client and server. So here in HTTP there is 5 methods to commonly used in REST based architecture, that is post, get, put, patch and delete. So these are the just commonly methods. Put the value, just post the, in order to store, in order to pass, in order to send, in order to receive, like that we have some commands. So here this does correspond to create, update or delete operations respectively. There are other methods which are less frequently used, like options and head. So this is the just diagram, just communication is going on in between client and the request. So send request to the server. The server, it fetches the just it receives the request from the client. It fetches the information whether the type of data is available in database or not. Then immediately it can send back to the response to the client. And this is the send response in terms of either HTML or XML, either SOAP or images, whatever the some amount of information are back to the client. That is the in terms of response. So this is the actual working process of REST by using client server communication model. Client server or client server request model. Next, these are the just I told already 5 commands I used to HTTP method. So here get, post, put and patch and delete. So here get method. So in order to get, in order to read a representation of the source in the safe path, the get returns a representation XML or JSON and HTTP response code of 200. In an error case, it most often 404 or 400 not request or bad request. So in case of error message, it will display either 404 or 400 bad request are not found, like that we already seen. So next one, post. So the post verb is most often utilized for create new resources. It is create to, in order to create or in order to add new data to the server. So that we use command that is post. So in particular it's used to create subordinate resources that is subordinate to some other resources on a successful creation. Return HTTP status, that is 201. Just it in case of failure, it displays request 201, returning a location header with a link to the newly created resources with 201 HTTP status. That is the about post command. Next, put. It is used to updating the capabilities of server. Updating the capabilities of server. However, put can also be used to create a resource in the case of where the resource ID is chosen by the client instead of the server. So in other words, the put is the URL that contains a value of non-existent resources of ID. So this is about the third command, that is put. Next one, patch. It is used to modify the capabilities. The patch request only needs to contain the changes to the source, but not only complete the resource. It resembles the put. The body contains a set of instructions describing how a resource currently residing on the server should be modified to produce a new version, that is patch. Next, the last one, body delete. It is used to delete resource identified by a URL. Unsuccessful deletion, it returns 200 status code 200, that is okay, along with a response body. So these are the five commands. It is very important to execute the data into the from the server to client to server, get to post to put to patch and delete. Next one, idempotent of HTTP commands. So the idempotent of HTTP method is a HTTP method. It can be called many times without a different outcomes here. So it would not be a matter if the method is only called once. So the 10 times is the over. So the result should be the same. Again, the only applies to the result, not the resource of itself. So here two commands here, that is a is equal to 4. So just that is a plus plus, just increment before the execute. So here it is idempotence as final a is equal to 4, would not change after executing it multiple times. That is the first a is equal to 4. Next to a plus plus, it is not idempotence because the final value will depends upon the number of times the statement is executed. So these are the idempotence of HTTP method. Example, these two are example. A is equal to 4 and a is a plus plus value. Next one, request response command, just command lines here. So now we'll show the request response work for different HTTP methods. Let's assume we have an API that is just www.iare.ac.in, that is the API just in order to get the student data from the source here. So this is the request to get, post, put, or patch, delete. So here request for all students of data. So the command for get is like this: get of /API /students. For post, request for posting or creating or inserting data. So that is post colon API students, just flower bracket, the name, like just you can whatever they type, just you can type here. That is the command for post. Next one, put or patch, the request for updating data, just in order to add some data to the existing data. So that is ID is equal to 1. The command for that is put or patch underscore API students 1. Name, just you can type your name, whatever the name you require, just you can type there. That is the third one. Next one, delete. In order to delete the data, for that delete underscore API underscore student 1. So these are the just command commands for HTTP methods: get, post, put, patch, and delete. So next, here we have in order to explain the building a RESTful API with Flask, step-by-step guide. So before that, we have to know about the complete introduction of API, that is over. Next, here we have some 6 guiding principles by REST protocol. So here these are the uniform interface, client server model, stateless, cacheable, and layered system, code on demand. So these are the 6 guiding principles of REST protocol here. Some constraints and principles that promptly simplicity, scalability, and stateless in the design. So the 6 guiding principles constrain the RESTful architecture are here. We have 6 types of 6 guiding principles of REST here. Let's start with the first one, uniform interface. So uniform interface we are having again here 6 types of 5 types of in order to interface devices here. Identification of resources. First, you have to identify the resource available resources to authenticate the device. So that is the first one in the part of uniform interface. Uniform interface, all the devices are maintain unique code or unique specifications. So based on that, we have developed the uniform interfacing in between the associated devices. So that is the term you have to remember. So the first one, identification of resources. The interface must uniquely identify each resource involved in the interaction between the client and the server. So that is the first one. Next one, the second one, manipulation of resources through the representations. So the manipulation of just we have to manipulate the resources should have unique representation in the server response. That is, we know the API consumers would use this representation to modify the resource state in the server. So that is the second one. The third one, self-descriptive messages. Self-descriptive messages stands for each resource representation should carry enough information to describe how to process the message. So that is the information. It should provide some information of the additional actions that the client can perform on the resource. So that is the third one. Next one, hypermedia as the engine of application state. The client should have only the initial URI of the application. The client application should dynamically drive all the resources and interaction with the use of hyperlinks. So the available hyperlinks that can be combined with the hypermedia as in the application mode. So these are the 1, 2, 3, 4 types of constraints under the uniform interface. It maintain uniform specifications while interfacing the devices. Next one, client server. Client server, we already know, just the communication is going on client and server. Just the client send the request to the server. The server receives the request from the client and fetches the information from the database or server, whether it is available or not. So it is available, then again immediately it can send to the client in terms of response, either images or special keywords or whatever the response just you get by client. So that is the client server model. So by separating the user interface concern from the data storage concern, we improve the probability of the user interface across multiple platforms, improve scalability by simplifying the server components. So while the client and the server involves, we have to make sure that the interface constant between the client and the server does not break. So this is about the first one, second one, client server. Next one, stateless. So here the stateless is mandates that the each request from the client to the server must contain all the information necessary to understand and complete the request. So that is the without any disturbance, just we have to put the request from the client. So that is the significance of stateless here. The server cannot take advantage of any previously stored context information on the source. That is very big issue. For example, in previous just www.iare.ac, it can send. So again we can send same request to the server. So it not depends on the previous one, www.iare.ac.in. So it can again fresh response sent to the client. So that is the state. For this reason, the client application must entirely keep the session state. So that is the third one. Next one, cacheable. The cacheable constraint requires that the response should implicitly or explicitly label itself as cacheable or non-cacheable information. If the response is cacheable, the client application gets the right to reuse the response data later for equivalent request and a specific period. So define period, that is the cacheable information. Then the last but one, layered system and code on demand. It is optional. The layered system involves it allows architecture to composed of hierarchical layers by constraining component behavior. In layered system, each component cannot see beyond the immediate layer. They are interacting with devices. For example, the layered system in the MVC pattern, mobile variable communication. The pattern allows a clear separation of concern, making it easier to develop, maintain, and scale up the application. So this is the about layered system. The last one, code on demand. The REST, representational state transfer web API, it allows client functionality to extend by downloading and executing code to the form of alphabets or scripts. So that is the biggest advantage of the downloaded code. Simplifies client by reducing the number of features required to be pre-implemented. Servers can provide a part of features delivered to the client in the form of code, and the client only needs to execute the code. So this is the um, five types of guiding principles by REST. So the next one here, before going to step by step guide of the API with Flask. So here just the common things here. It is widely REST. We already know it is architecture style for designing a network application or web applications, to creating the web applications here. Flask, a micro web framework for Python. So just here Flask. So it is a Flask, a micro web framework for Python, provides an excellent platform for building RESTful API due to its simplicity and flexibility. In this blog post, we will take care you through a step-by-step guide on how to build a RESTful API with Flask, covering the fundamentals and best practices. So this is the just block diagram of RESTful API with Flask here. This is the client. This is the REST API by using. This is the database. Just by using commands, get, post, put, delete, by using the response in terms of JSON or XML. Get, put to, post to, like that. We have some HTTP commands here. By using that, the information may sent from the REST API. So this is the introduction point. Next, step by step. So here in the part of step by step guide to in order to building a RESTful API with Flask. So here we have 5 steps are available. So the first step, in the first step here, setting up your Flask project first. So by using Python. So here I am using only Python to write the code. So not don't use any other languages. So the first step in creating the RESTful API with Flask to set up your project. So you will need to have a Python and Flask installed. So in your system, compulsory Python Python is almost is available. Python with Flask installed. So that is the mandatory thing. So you can create a new Flask project using command line tool, or manually create a directory structure. Here is a basic example of creating a Flask app. So here these are the command lines to create um, minimum API with Flask here. From Flask, just you can import first you can import the data from Flask, import to Flask here. So the app is equal to Flask of name, just whatever the name, just you can write whatever the name. So here I write here Prashanth. So if name is equal to main server, so app.run debug is equal to true. So this is the just a command line, just you have to remember in order to create the basic Flask application here. In this code, we import the Flask class, create of instance it, and run the app if the script is executed directly. So this is the first step you have to do among 5 steps setting up your Flask project. Next one, second one, just you can defining endpoints. What are the endpoints available in that particular period of time? You can define. So API endpoints are like URLs that your API clients will use to interact with your applications. In Flask, you can define endpoints using the routed decorators. So by using decorator, just you can define the API endpoints here. So for example, in order to create an endpoints for retrieving a list of items, you can do the following. So at the rate app.root in just app app.root in single quotes, slash items methods is equal to, by using get command. By using get command, just we have to here definition get underscore item. So these are the two lines. Retrieve and return a list of items from your database. So these are the two code line. So here we use the get underscore JSON method to parse our JSON data sent by the client and process it as it is needed. So this is the defining API endpoints here. Next one, sending responses. So in second step, just we send to the request from the client. The third step, we are going to receive responses from the server. So the same thing here. While clients make the make a request to the your API, you need to send back appropriate responses. That is the aim here. Flask allows you return JSON data, HTML or any other format as a response. JSON or HTML or images or special symbols in terms of response. Next, the to send JSON responses, just you can justify JSON if the function here. So import Flask, import of JSON if y. So here definition get underscore items, item is equal to retrieve. By using retrieve items from database. So the last one, return. Now to just you can return JSON if y cover bracket items. So these are the just before that at the rate app dot root single quote same. Just I write in by using get command. So here, so these are the just sending responses to the client from the server. So this is the third step. Fourth step, in the process of sending a request from the client or response from the server, so we are having some error. So in order to handling that, we are the fourth step is error handling. So here the error handling is a crucial aspect of API development. That is minimum thing. It makes it easy to handle errors to provide meaningful error message to the client. So that is our agenda. So here you can use the abort function to raise HTTP error and provide custom error messages here. For that we have some code here. So import from Flask, import from abort. Just you can import from abort. So at the rate app you root of same item dot items underscore integer values, that is by using get command. So definition get underscore item. Just you can give the item ID, whatever 1 2 3 whatever item ID having, you can give here. Next to item retrieve item by item ID. So if not there is no error, so about 404 or description item not found. So item not found, just finally just you can return the JSON if y. Okay, so this is the just whether is item is available or item is not found. Just you can further you can write this command line for the error handling. This is the fourth step. So in this example, if the requested item is not found, API returns 404 with error with a custom error message. So this is the fourth step. The last one, authentication and authorization. Sending request to response, error handling. The last one, authentication and authorization. So first create Flask, new Flask method. Next, send request. Send request. Next, receive response. Receive response. The fourth one, error handling. Error handling. The last one, authentication. Authentication and authorization. Authorization. Okay, so many APIs requires authentication, authorization to ensure that only authorized users authorized users only can only it can connect to the devices. So you can use Flask extension like Flask JWT or Flask authorization library to implement authorization and authentication in your API. So by using these two, this one or two, just we can implement the authorization and authentication process, that is step 5. So these are the 5 steps, step by step, to in order to building a RESTful API with Flask. So step by step. So before that, we have to know the just introduction of API, REST API introduction, and along with that, here we have 6 types of guiding principles by REST. So that also we discussed in the first 4 to 5 slides. So these are the 5 steps guide, step by step guide to implement RESTful API with Flask. So by using Python, so it is very important to in order to develop the some real time application based on the IoT devices. So that is essential. So these are the references I used for this lecture. Some geek for geeks and RESTful API.net. Some I'm searching some SCI or Scopus papers also that I'm not included here. I included only 3 of references. Some medium.com. So I referred so many references, but I included here only 3 step by step guide. So this is the lecture in order to building a RESTful API with Flask, step by step process. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.